All right, effective rate. As the number of times per year that interest is compounded goes up. Wait a minute. As the number of times per year that interest is compounded goes up. So as n increases, the amount of interest does as well. We saw that on the last page. This is Chapter 7, Section 4, Compound Interest, page 2. Because of the difference, the interest earned on a savings account is a little bit higher than the stated rate. Okay. So for example, if you have your 5,000 with an interest rate of 4% compounded semi-annually, or n is 2, will be computed twice a year for 2% for the first year, and so on. Okay. The stated rate, or the nominal rate, is 4%. Okay, so what we've been just calling the rate is the stated rate or the nominal rate. But the actual yield, or the effective rate, is actually just a hair higher by the time it's compounded. It turns out the effective rate is the simple interest rate, which would yield the same future value over 1 year as a compound interest rate. Let me read that again. It turns out the effective rate is the simple interest rate, which would yield the same future value over 1 year as the compounded interest rate. The formula for effective rate of an investment is notable for the lack of principal needed. So it doesn't matter how much the principal is, how low, how high, or whatever. When you're calculating the effective rate, what does 4% turn into with the n of 2 over time? It'll turn into a little higher rate. Okay, so let's look at an example of that. Try to leave that on there. Proved which is better investment by comparing their effective rates. So one is 3% compounded monthly. So n equals 12. 3 is an R of 0.03. If you use the effective rate, if they use the word effective rate, this is the formula we're using. Okay, so E equals 1 plus 0.03. You can put the 0 in front if you want. 12 for monthly, raised to 12 minus 1. So if you're putting that in your calculator all at once, you're going to go parenthesis 1 plus parenthesis 0.03 divided by 12, close parenthesis again, raised to the 12. Hit the arrow over to come down to go minus 1. Do not put the minus 1 up here in the exponent, okay? Most calculators have the arrow over. Go over to come down and put that in, and your answer should be 0.0304159, blah, blah, blah. So let's round this. It doesn't give any rounding instructions, but this is basically 3% or 3.04%, just in case we have to compare it to something else here. All right, how about, so how about this semi-annually? So E equals 1 plus 0.0325 divided by 12 raised to the, oops, not 12. Our n has changed to 2. Minus 1. Don't forget that minus 1. It makes a difference. And when you figure this out in the calculator, this will be 0.3, 0.035140625, which is approximately 3.51% or 3.5%. Quite different than the other one. 0.5% makes a difference. Here's a different one. R is 3% daily. N is 365. E is 1 plus 0.03. 365 raised to the 365 minus 1, 0.03045326636. Don't need all that. Need 3 point. This gets moved here. If I want two decimals, I'm looking at the 4 and raising it to a 5. Okay. And then the last one, 3.1 quarterly, n equals 4. E equals, if we're putting in the calculator, 0.0, oops, yes. Sorry. How many times do you do that? Divided by quarterly, 4. Close parenthesis again, raised to the parenthesis. Well, we don't need parentheses, it's just one number. So let's just raise to the 4. Use that arrow number to come down and go minus 1. 0.031362 or 3.14 if we're rounding to 2 decimal places for an interest rate. Okay.